Good morning, good afternoon, good evening. This is Mr. Payne bringing you quadratic word problems, Unit 8, Lesson 8. Objective. Students will be able to write the equation from the quadratic word problem and identify the solutions. Exercise number 1. Consider a rectangle whose area is 45 square feet. If we know that the length is 1 less than twice the width, then we would like to find the dimensions of the rectangle. If W represents the width of the rectangle using the variable W, then write an expression for the length of the rectangle L in terms of W. One of the things I want to do is let's draw a quick little picture. It says that we have a rectangle, so let's draw a rectangle. And it says that my length is 1 less than twice the width. They put that word less than in there, so let's be careful. So it's twice the width, 2W. They said we're going to write it to W minus 1. That is my length. Well, they didn't really tell us what the width was, but they used it and said that we're going to base everything off my width, so my width is just W. So let's go back up to, and the area of this is 45. Let's go back up to A, and it says write the length in let statement. So let L equal, what do we say we let the length equal? 2W minus 1. B. Set up an equation that could be used to solve for the width W based on the area. So I'm going to say my area formula is length times width. So area 45 equals W times 2W minus 1. Remember now that 45 can go on either side. Let's do part C. Let's solve that right away. The first thing I'm going to do is distribute. I'm going to get 2W squared minus 1W equals 45. Remember the last couple units for my zero properties, it's got to have 0 at the end. I'm going to be saying equals 0. So how do I move that positive 45 over? I'm going to do minus 45. Two W squared minus 1W minus 45 equals 0. There I go. I have my equals 0 property. Now I can go ahead and factor. Well, this is also not a nice problem because we have to use the AC method. 2 times 45 is going to give me 90. So, what numbers multiply to 90, subtract to give me 1? Well, hopefully you told me 9 and 10. So I'm going to have 2W squared minus 10W plus 9W minus 45. Remember, pull the GCF, pull the GCF. The GCF of the front guy is going to give me 2W. 2W out front. What's left? W minus 5. Pull the GCF of the back guy, which is going to give me 9. Put 9 out front. It's going to be a plus 9. What's left? W minus 5. That's how we know we did it right. When I have W minus 5, W minus 5, the same thing inside, I know I did it right. What do I have left? I have W minus 5 times 2W plus 9. Alright, I'm going to go ahead now and move this up here so we can tee it up. And let's remember from yesterday how we do that. We go right down, I'll do it in my green just like I did, my T-bar. Tee it up and we solve for those solutions. Because it does say equals 0 all the way through my problem, I say W minus 5 equals 0 and 2W plus 9 equals 0. Plus 5 plus 5. W equals 5. And then I have minus 9, 2w equals negative 9. Divide by 2, divide by 2. W equals negative 9 halves. Get my red pen out here. Which one of these two values can I reject? Hopefully you notice that this guy, we reject this guy, because you cannot have a negative 9 halves as a value of a width. So that is not a correct answer. The correct answer is W equals 5. That is a possible width of the length of a width. So now we're going to go ahead and plug that in to find my length. If I say 2 times 5 minus 1, I get 10 minus 1 is 9. My L, my length, equals 9. Exercise number 2. A square has one side increased in length by 2 inches and an adjacent side decreased in length by 2 inches. If the resulting rectangle has an area of 60 square inches, what was the area of the original square? First, draw some possible squares and rectangles to see if you can solve by guess and check. Then solve it algebraically. The first thing I'm going to do is draw some rectangles and squares just to help us understand what we're doing. So here's a square. What's unique about a square is that all sides are the same. So if this side is x, this side is x. Now I'm going to draw a quick little rectangle. What it says is that one side is increased by 2, so it's x plus 2, and the other side is x minus 2. It decreases by 2. And the area of that is 60. So hopefully you understand that my area formula is length times width. If we set that up, we have x plus 2 times x minus 2 equals 60. Hopefully that you noticed from by now, since we've been completing the square, that x plus 2 and x minus 2 is a repercussion of a DOPS problem. So now if you go ahead, and I'm going to do my work on the left-hand side, I'm going to create a little box just to make sure. X plus 2, x minus 2, I get x squared plus 2x minus 2x minus 4. These two guys will cancel out. I'm going to be left with x squared minus 4 equals 60. Remember, my zero property, I want that to equal 0, so I'm going to do minus 60 on both sides. I'll get x squared minus 64 equals 0. Alright, now I can go ahead and factor it. Oh, it's a DOPS problem again, so it's going to be x squared minus 8, x squared plus 8 equals 0. Next step, I have it factored. I can go ahead and tee it up. And one little correction, this is not x squared inside my parenthesis, it's just x minus 8. Sorry, I misspoke. Now I have x minus 8 equals 0 and x plus 8 equals 0. Solve. Plus 8 on both sides. X will equal 8. Minus 8 on both sides. X will equal negative 8. Get my red pen out. This guy, I cannot have a length of a square or a rectangle that is x or is negative 8. So we're going to reject that guy. That is a bad answer. Here is my answer. I have x equals 8. Now it says to find the area of the original square. So if I put 8 in here and 8 in here, the original area would give me 64. Because I would do 8 times 8 equals 64. And of course, who can forget our work with consecutive integers from the linear unit? Find all sets of two consecutive integers such that their product is 8 less than 10 times the smaller integer. So we really have to be careful here and set up my let statements. The first thing I'm going to do is let x equal my smaller integer. And then if it's consecutive, I have to say let x plus 1 equal my larger one. So let's read it again. It says find all sets of two consecutive integers such that their product means multiply, so I'm going to go ahead and say x times x plus 1 is my equal sign, 8 less than 10 times the smaller. 10 times the smaller, 10x minus 1. Remember that less than means start at the back and work towards the front. Now we can go ahead and solve. You can hit the video, hit the pause button, try solving it on your own, and then come back to it. If not, just follow along, because here we go. X times x gives me x squared. 1 times x gives me 1x. Notice, we're using a lot of methods throughout the entire year now, and we're putting them all together. So now what I want to do is I want to move that 10x and that minus 1 to the left. So I'm going to say, okay, negative 10x, x squared minus 9x equals negative 1. Let's add 1 to both sides now. I apologize. This should be an 8 here, not a 1. So we're going to add 8 to both sides. X squared minus 9x plus 8 equals 0. Now I have my equation where it's a trinomial and I can go ahead and factor it. So I'm going to say, all right, my a equals 1, so I can go ahead and do my 2 parentheses. And still equals 0. What times what gives me 8 and adds to give me 9? Well, hopefully you told me negative 8 and negative 1. Now we're at the step where it's factored. I can go ahead and tee it up. I have x minus 8 equals 0 and x minus 1 equals 0. I'm going to add 8 on both sides. My answer is x equals 8. I'm going to add 1 on both sides. X equals 1. Now the question asks, I wants 2 consecutive integers. So I have 8. What's the next consecutive integer? Well, if I said 8 plus 1, it would give me 9. That's one set of answers. And then I have 1. If I said 1 plus 1, which would give me 2. And that's my second set of answers. So I have 2 set of answers there. 8, 9, 8 comma 9, and 1 comma 2. Hopefully that you completely understand these lessons. Yes, word problems are not easy. We are going to work through about 5 of them in class with you. But please make sure that you have your notes completed and you write a good WSQ. Some key things that you want to do is maybe write down the process, writing down our let statements, setting up our equation, solving to get 0 on the right-hand side, and then factoring and teeing it up. That may be a very good strategy, is write down your steps for your WSQ. Have a good evening.